the information framework implementation plan. How do we create a plan? What? How do we create the short-term, long-term objectives? How do we align it with the information framework and the existing uh, definitions? So how do we map the existing definitions to the information standards? And what are the kind of implementation team, how we should create that, and the governance part, the data governance, why it is important, and also we looked at how do we use the maturity models, the data governance maturity model as part of our digital maturity model, DMM. Um, so those things we discussed as part of implementing the information framework module. And then we looked into the modeling patterns, and so we understood that any of the models which are being actually the modeling or the associations between the entities, if they are being repeatedly used, they will actually be modeling patterns. We use them for consistency and understanding the information framework easily, and also to help us in extending the framework. Okay, so we looked at five different modeling patterns. So the first one was entity specification, entity pattern, which we use for defining anything. Definition and specification are synonyms. So entity specification, entity patterns are used for defining the specifications or the characteristics of a given type of entity, whose characteristics would be shared by any number of instances that will be used as part of this definition, right? So for example, if we look at a broadband router, so any router that we buy will have the some specific model of the router will have the same characteristics or specs. Okay, and then we looked at composite atomic pattern, which is nothing but combining some of the entities of the same type in to form another entity or to define another entity, like creating a bundle of products, okay, product offerings, and so that becomes a composite atomic pattern. Then we looked at entity role pattern, where any um, any entity plays a multiple role, so that can be represented and can be easily handled or managed with our modeling without impacting any of the current modeling systems. So entity role pattern helps in that way. Then we also looked at the business interaction pattern, where we said that we have an entity by the name business interaction defined in the common domain, which we use as the parent for definition of any type of business interaction. So business interactions like request, order, notification, any such business interactions will be subclasses of the business interaction defined in the common domain. Okay. So, and then we looked at the last pattern, the fifth one, the characteristic specification, characteristics value pattern, uh, which is basically um, to capture or to add any of the dynamically varying attributes. We use characteristics specification, characteristic value pattern. We looked at a few examples of George G's video on demand scenario of category or the format of video and things like that. And also the color as an example we looked into the dynamically changing attributes. Okay. But we also use characteristic specification, characteristic value pattern for defining certain attributes of a given entity, which are dynamically changing. Okay. So essentially, these are the five patterns which are commonly used in the information framework. So if we go through the model of information framework, we will find these five patterns very commonly used. Okay. So yeah, that's what we discussed or covered in yesterday's session. So now as a continuation, we will try to apply these modeling patterns for a given scenario. So there is an exercise which is provided. All of you can see my screen, right? And if you go to the exercise document, exercise workbook, you have the exercise 1.3 information framework, modeling pattern and their application. So here there is a detailed description of the scenario that has been given where an organization who is actually manufacturing the test equipment and also provide a test application as part of their offerings. Okay, so they are working on some testing equipment, and as part of that, they would like to capture the address format and also the phone number format, which they want to use it as a global application, which can be used for capturing the information from any of the country, and these address and telephone numbers formats actually vary from one country to another country, and also there are some difference of the way in which address would be specified from one country to another country, and how do we capture that, or how do we model the information required for this. So if we need to assuming that we are creating this test application, and as part of the test application we need to design the information model now, the data model that we need to be creating here. And so using the information framework and the knowledge that we have acquired so far, we need to work on this exercise. Okay. So I would say this exercise to be looked into from three parts. We need to divide this into three parts. Okay. So the first part is basically determine the information requirements. Okay. If you go to page number 14, what we need to do in three different parts is provided here. Okay. So now first let us take up the first part, which is determine the information requirements for the application. So what would be the entity or ABE, right? So that is what we need to identify here. So, and so let's do that first to start with, and then we will move on to the next sections of the exercise. Okay. So, yeah. So for part 1, it is suggested that you highlight the candidate information requirements and fill in the table with the candidates. So what are the information that you identify that needs to be filled into this column in this table? Okay. So one example that has been given here is address format definition. So this could be one of the information or ABE that is required to meet the requirements given here. Okay, so now you need to identify many more such information that would be required. Okay, and as in that is the first part of the exercise. As a next part, what we will do is for each of this information that we identify, what is the modeling pattern that will be most suited and what would be used here is what we will look into in the next stage of the exercise. And as a third part, we will have to model that. We will have to draw the UML diagram. Okay, construct the model by applying the patterns. Okay, so that is what we will be doing in the third part. Okay, so now we just need to identify the information requirements. So this is the first exercise that we are doing as part of this. You need to identify all this information. What would be required? Based on the, I have not read the complete scenario here for the application requirement, but I have just briefly explained what is happening here. So you need to go through this scenario completely and try to understand what are the kind of information that's required as part of this application design. Okay. So yeah, and my suggestion is that anyway we'll create breakout rooms and you can all get into the breakout rooms. Maybe we'll create 4 breakout rooms with 4 people each currently. Any others joining, we will I'll keep adding them to the breakout rooms. Yeah. Any questions on this exercise? Are you all clear on what needs to be done? What do they mean? But actually, let me go back to that no, it's here only, right? Okay. So right now, for this the current part of the exercise, we do not need to worry about this part. Okay. But still, these are nothing but the modeling patterns names. So the first one that you see here is entity specification entity pattern. The second one is composite atomic pattern. Third one is entity role pattern. And fourth one is business interaction pattern. And the last is characteristic specification, characteristic value pattern. So these are just the pattern names. And we do not need to worry about this right now. In the first part of the exercise, we just need to identify what are the information requirement. In this sample table, there are only 3 rows given, but we may need many more informations. You can actually add additional rows to this based on the information requirement that you identify. Okay. So right now we don't need to work on this part, the right side columns. Only the first column, information requirement, is what we need to work on. Okay. So if it is clear for everyone, let me create the breakout rooms and let us have 20 minutes to work on this exercise. So 20 minutes from now, we will get back for the discussion on what you have identified as the information requirements. Okay, so which would be what are the time now? 8:56, right? 8:55. So yeah, 9:15. We will get back. Okay. So I'm creating the breakout rooms. Automatically assign 5 to 6 people. So we have 16, 4. Yeah, I think that should be fine. I'll make 4. Yeah, I've created the breakout rooms, and once I open them, you will all be moved into the breakout rooms, discuss within the team internally, and identify these information requirements. Okay, and in about 20 minutes from now, we will come back onto the main room to discuss this. And anyway, I'm here only. If you have any questions, you can put that on chat window. I will be responding, and I will also keep joining the different breakout rooms to see how it is progressing and if any help required. Okay. Yeah, I'm opening the breakout rooms. So please start working on the. So shall I share the screen and will you discuss this? Yeah. Can you see my screen now?
Yes, teacher.
Yes. Yeah. So good. It's good that you have identified many of the the information requirements here. Okay. So can you explain how did you identify these additional information requirements? So one address format definition was already given as a sample. So from location definition point of view, can you start explaining what is this and why do you need this with reference to the exercise description? Do we need a location definition? The first question is that, do we need location definition as information? Yes or no?
I think no,
Why we don't need? Why not?
because we have an address format definition.
Yes, it is address format definition is there, one. And second thing is location as information entity. It has been already defined in the information framework. Okay, so we have location in the information framework, and for any different types of address format to be captured, we have address format definition. So we will not need the location definition here. Okay. Now coming to this, the third one, components format definition. Do we need this? Very general is what is the response on the chat window. So do we need this or not? Components format definition is not actually required, but components, if you look at, yeah, you have mentioned here as valid values or names format definition. So this is required actually, like we want to look at the component valid value names here. Okay, so it is not the complete format definition. So we would need a component valid value or name. Okay, so that is one information that we require, because okay, what happens here is when a user is trying to populate certain information about whatever the components of the address or maybe even the telephone number, we want to verify whether that is the right or a valid information or not. Okay, let's say for example, uh, if the country is chosen as North America or United States of America, then the states for that, the valid states for that would be one of those states within the United States, right? I cannot define a state in Vietnam under the North America. So that is not a valid name. Or I cannot define a state within India under the United Kingdom country, right? So that is where we need to have this information about valid names, component valid value name here. Okay, so that is one information we would require. Whether it is format definition, we will look at it. Um, we are not actually looking at the format here. We are looking at this as a information that is required. Component valid value name. Okay, so that is one part. Then, so we don't, the definition of a component should include, okay, data type and maximum length. So this is just some requirement as part of the overall this one. So we don't need this as an information. See, okay, just to clarify, when we say information, we are basically defining an ABE. So this ABE is required. And if you remember, I had mentioned yesterday, ABE practically means a database table. So when I define a database table, I will define the name of that table and then certain attributes or fields for that table, right? So the attributes are nothing but the fields of the table. So in this case, what a table name do we look at? So this is not a right information, a requirement. Okay. So you can take this out. Okay. Components format definition is something which you can still look at whether it is required or not. And if we have a components format definition, do we still need components definition? We don't need this, right? Okay. And this is again not an information. What we need to do is, this cannot be the table name. So the architect also wants to categorize or type the various definitions. So the table name can be, yeah, what can be the table name? Definition type, the format definition type. Because we are talking about the definitions here and they are saying categorize or type of the definitions. So this, yes, this requirement is right in terms of capturing it as an information requirement. But table name cannot be like this. Table name will have to be something like definition type, the format definition type. Okay. And then address is also there already now, and that is where we are defining the address format definition. So you don't need a separate one for address. And similarly, okay, now phone numbers. Phone numbers is what is mentioned here. Okay, we have address format definition, and in the requirements, we just saw that requirement. Where is that? Let me just um, let me just get you that PDF of exercise. So yeah. So if you notice in this, there are certain uh, requirements where the street address could be something like this in one country, and in some other country the street address can be something different, and that is why we are trying to define the address definition format, right? So similarly, if we look at the where is it, telephone numbers, right? Telephone numbers also vary from one country to another country, and that is why we need telephone number format also, format definition. So the way in which we have address format definition, we will have one more as telephone number format definition. Okay, so that is how we will have the uh, information requirements. So those will be the ABEs that we need. I have not discussed the patterns. We will discuss the pattern little later. But are you all clear on how we should look at what is the information or ABE definition that we would require if we are modeling? Okay. How many of you have uh, done this modeling work or used UML diagram? Has any one of you drawn any UML diagrams as part of your solution designing and things like that? Okay, I can see one person writing, I have drawn one. How about others? Generally, as part of your work, yep, of course, okay, good. Good, okay. So if you have already used the UML diagrams, then it will be much easier to understand what I'm trying to, what we are trying to do as part of this exercise. Okay. So what we will do now is it clear in terms of what I have discussed, what is required and what is not required with reference to this? Okay. So what I will do is, let me go to this and yeah, identify the information requirements. Yeah, this is there in your exercise solution, suggested solutions also. But this is what we were discussing, right? So we need address format definition and format, telephone format definition, and what is the format for that telephone format. Then, yeah, so this is one thing which we discussed, right? Format definition type. So this could be applicable for either telephone format or address format. Or if you want to create it as two separate ones, that is still okay as part of modeling or design. So I can have one for address format definition type and another one for telephone format definition type. We can do it that way, or you can have a generalized format definition type. That's also okay. Yes, you have some question? Any questions? Okay. I assume no questions. You don't have any questions. I don't. You can unmute whenever you want to ask a question. Okay. So format definition type is fine. Now we also discussed about component valid value name. Okay. So whether the given component is valid or not, we need to identify that, and so that is why we have this. And if you look at the requirements, where is okay? There are many areas where they have mentioned that they want to capture the relationship between the components. Okay, so yeah, we just said this one is what verification of the selected format components, valid names. Okay, so valid value or names is one of the this one, and then yeah, if you notice there is a requirement here for there is a need to show the relationship between components like this. So one example that they have given is the abbreviation and expansion for that. So that is one relationship. Okay, so that's one type of relationship, but there can be multiple different relationship. Okay, as you see here, architects have found out that there can be other types of dependencies. So dependencies between values or names. Okay, if you remember, we discussed that the city name for a state name for a given country. Okay, so that actually becomes a dependency. Okay, so such things are also required based on these requirements mentioned here. So how do we represent it? Is by bringing in the component relationship. So it could be a relationship, could be simple like abbreviation and expansion. Okay, other one could be a dependency. Okay, so there can be a group dependency that's shown here as another requirement. Contact medium, which is already there in the framework, and that is what we will be expanding for the telephone format and even the address format, and we will attach that to the contact medium. And that is why it is just mentioned here, but actually contact medium is not the new information requirement. It is the one which is already defined in the information framework. All the other ones that you see here, right? All these are the new information requirements for this application development. Okay, so any questions? Or you're all clear on how to identify the information requirement? All this will actually become some tables. You will have one table with the address format definition and format, and this is another table. So like this, you will have multiple tables now, and then we need to start identifying the type of a modeling pattern that we use. Okay. So is it clear for everyone? Okay. So the next step that we need to do is, some people have already done this. Where is that? Let me on this. Yeah, you have already tried identifying the type of a modeling pattern. So maybe what we can do is quickly we can discuss this now and then take a break and come back and continue with the next part of the exercise, the modeling, drawing the UML model. Okay, so that we can see as the next part. So before taking a coffee break, we will discuss this. Okay, now address format definition. You have identified it as entity specification, entity pattern. Why do you think it is entity specification, entity pattern, and why not any others? Any thoughts on this? You have identified here, so I'm sure you will have some approach based on which you have identified it is entity specification, entity pattern. Why did you look at this as this pattern? And it's the right answer actually. It should be entity specification, entity pattern. But why is one question which you need to answer. Would any one of you answer that, or do you want me to explain? Okay, since no one is responding, let me explain and then move forward. Okay, yeah. Here we are talking about address format definition. Definition, if you remember, I had mentioned that definition and specification, these are all synonyms. So address format definition, what we will do in this requirement is, we define the format once, let's say for United States. This is how the address format would be. So we define the format once, and for any of the address to be captured for the customers in United States, we will use this same format. So which means I'm instantiating them. So remember, entity specification, entity pattern, we do exactly the same thing. In the specification, I define, and in the entity part, I instantiate them. And any number of instances will use the same specification. So once I define this address format for United States, for any address, any number of addresses for the United States, I will use the same format. Right? And that is why we will use entity specification, entity pattern here. Yes, address format specification and customer address instances. Right. Customer address instances are what you are mentioning it as uh, the instantiation of that address, right? So we will not represent it that way. We don't mention it as address format specification and instances. We actually mention it as, let's say, uh, address format specification slash address format. So this is how it will be. Address format specification and address format. Okay. Yes. The next one, what we discussed was, okay, if I go back to my, yeah. So telephone format definition. This will also be same as the above, right? Yeah. So entity specification, entity pattern. Okay. And the next one, format definition type. What do you think will be the modeling pattern for format definition type? Uh, 3 support 1 and 2. Yes, this third one supports 1 and 2, correct? The address format and the telephone format, right? So we are again now categorizing them. So that becomes the third, this one. So how do we, what modeling pattern do we use here if it is supporting? Good, very good. No modeling. No, not composite atomic. No modeling that is required here. But we still require this information as a table or as an ABE. Format definition type, we will use it as an ABE. And I'll just, what we will do is we'll just capture that definition type here, and then we will support it, or we will associate with the or we'll say, yeah, associate with this either the address format or the telephone format. So we will see that as part of the modeling, how do we do it? But definitely we do not need any of the modeling pattern here. We'll just define it as a table, simple table, a simple ABE. And as part of modeling, we will take care of the association. We'll see that. And in fact, that's the same for all the remaining entities here, all the remaining information. Component valid value name or component relationship, all of this. Okay. Yes. 1 and 2 should also use composite atomic. Yeah, that's the point which I was coming to. Um, why? Why do we need composite atomic for, let's say, address format definition? If I go to the requirements, okay, somewhere it is mentioned that, um, yeah, something like this, right? So in an address, I may have multiple components. Like if you see here, this is one address which has components like street number, and this is yeah, this is basically street number. This is street name, right? And then is a this is a suffix, directional suffix. Okay, and yeah, this is the street name, and this is the suffix, directional suffix, which basically means southwest, right? So if we notice this, now when I talk about a street address, it consists of all these components, right? So this is one example. There are other examples also to show the relationship. Somewhere, where is it mentioned? Mm, the city line format and things like that. So, okay, it should have the country, state, province, district, territory, landline, I mean land, and some things like this, right? So here again, it could be you can have this information captured in separate entities and then group them together whenever you want. Okay, and that grouping them together of this independent information is what will become composite atomic. Okay, so and same thing holds good even for the telephone numbers. Okay, like if you notice, no, okay, that's the part. Fine. So that is why we, where is that? Sorry, get back multiple sites. That is why we need for both address format and uh, okay, we said this is required, and composite atomic also is required for these two. Okay. Um, yeah. Contact medium, anyway, we will be looking at it as a entity relationship, entity role uh, as we go forward, because contact medium can capture either the address or the telephone number, or so things like that. So it basically can play a different role, and that's why we look at it as a entity role. Okay. Yeah. So that's it with the. Okay. Now one more question that I have is, do we require any characteristic specification, characteristic value pattern for any of the requirements? This pattern, will it be required? Any thoughts on this? Anyone? Actually, if you look at the requirements, there are many areas where we feel that there are information that would dynamically change, right? Like if you look at the address for US, we want it dynamically change. Different kind of an address format, and for some other country, different. So it is all dynamic in nature. Is what we actually uh, feel when we go through the requirements. Okay. So we may think that yes, we may need characteristic specification, characteristic value pattern here. We may, but again, what happens here is we need to be uh, careful about using this pattern. Characteristic specification, characteristic value pattern basically provides a choice for the user to choose from the multiple values or options that we will have. And so typically in enumeration or something like a drop-down list. If we are providing such a feature using our application, if we want to give a drop-down list to the user to choose from or to pick the value from, then we want the characteristic specification, characteristic value pattern. It's nothing but name value pattern, as I had mentioned. If that is not the requirement, we will not need that. Okay. So in this exercise description, it is not very clearly mentioned. So in such scenario, we can go back to the business owner and ask them, do you really want this kind of a drop-down functionality where the user can choose from while populating this information? And if it is if that optional thing needs to be provided, then you choose the characteristic specification, characteristic value pattern. Okay. But remember, using that pattern will impact the performance of the system. Although it provides you a user friendliness in terms of choosing some values, so it may impact the performance of the system. So you need to cautiously use that pattern. Okay, until and unless it is a must requirement for providing a drop down, do not use the characteristic specification, characteristic value pattern. Okay, so with this, we have actually discussed all the information requirement and the patterns also. So now I would say this as optional. So that's why I'm putting it in a different color, or maybe we can write optional depending on the requirement, which you can clarify from the business owner. Right? Any questions so far? No questions? Hope everyone has understood this exercise, and if we need to model something for a requirement, you have some clarity now. Okay, fine. Um, that, actually, we can take a break now. Now it is almost 10:30, right? It's 10:27. 10:50. Okay. Number, street. Okay. Valid name. Valid name or value should it be a composite? No. If we when we discussed, we said it is just one other entity without any format. Sorry, without any modeling pattern being used. But this is a good attempt, very good this one which has been shown here. Okay. But one thing that we would like to look at is, let's say if I take address format definition. So we mean, okay, what we are seeing here is a composite atomic pattern. What about entity specification, entity pattern? We do not have that here, right? So we need to have entity specification, entity pattern also. Okay. Yes. So how do we represent that? We will take a look at that. Now if you see, yeah. Now what I have done is I've used visual paradigm application for modeling some of these things. So I'll just show you as an example, and we can actually use something similar to this, and it can be slightly different also. All right. Okay. So if you remember, this is what we had looked at as a entity specification, entity format. Sorry, entity specification, entity pattern. Okay. So now in this specific case, I can say address format specification that describes the address format. So I can make it that way. I can have one representation, another representation for telephone format specification and telephone format. So these right side ones will be the instances and left side one will be the definition part. Okay. But can I generalize it, stating that for any of the entities, I will say format specification and instances here. That can be done. And specifically for this exercise, by using this, I can represent both address and telephone format specification. But if we do it separately also, there is nothing wrong. We can do that also. See, when it comes to implementation, there can be many different ways in which we can implement. What matters is it meeting my requirement and is it bringing in the simplicity in the overall solution, and how easy it is to maintain that. And if we address these factors, then it should be fine in terms of the way in which you implement it. Like as I said, you can split this into address format specification and telephone format specification separately, and you can implement that also. Again, it depends on the business requirement and future, what kind of changes would be required. based on that. Okay. So this is what we have missed out earlier as entity specification, entity pattern, and that's what I'm showing here. Okay. Um, but there is one more thing which we need to look at. That's basically there is something called root entity which has been defined within the information framework. And anything that we define, if we are aligning it to the information framework, it should be subclass of the root entity. Okay, which means whatever attributes that have been defined here has to be mandatorily defined in all other entities that we define. Okay, so in information framework, as part of root entity, which is going to be the root for any entity or any class that we define. Okay, so this will be the parent class for everything that we define. So with that, what we do is we mandate these three attributes as part of all the definitions. Unique ID, name for that particular thing, and then the description. So all these are mandatorily to be defined, and that's why it is considered as a root entity. Okay, so now here entity specification specifies the entity. This format you will find in the information framework. This is directly available. But now for our specific requirement here, this will become entity format specification specifies the entity format. Okay, so that is how we will be looking at it. So let me take you to the next one. Yeah. So this is how we will be looking at it. I have not shown the root here because I have already explained it in the previous diagram. So basically this is how it will be. Entity format specification describes the entity format. So I should have shown this here, right? But what is happening is we have also looked at a composite atomic pattern. So now if you notice the left side part, you're all able to see my screen, right? Let me know if you have any. Yeah. So left side part, if you see, is a specification part or something like a catalog view, which we mentioned yesterday, right? And right side part is all instantiation. All these are instantiations. Okay. So as part of this, if you notice, we have a composite and atomic as entity format specification. Now, as I mentioned, we can say even this is address format specification, composite address format specification, and atomic address format specification. And do I always need to use composite atomic as the name? No, not necessary. Not necessary. I can even say that full address format specification, and here we can say sub address format specification. That's also fine. Okay. So now instances are shown here. Always the relationship that will be shown will be at a lowest level, not at a highest level. So although we say describes here, if I'm using only entity specification, entity pattern, that association I will show here saying entity format specification describes the entity format. But if you notice here, what has happened is composite entity format spec describes the composite entity format. So this is where that relationship comes in between the spec and the instances. So similarly for the atomic part. Okay. I'm explaining this a little more in detail because during the exercise, some people had mentioned that they are very new to the SID and they have not done any modeling. So keeping in view of everyone and everyone to understand, I'm explaining it in a little more detail. And for some of you, if you have already done the modeling and UML and all that, you may be aware of some of these concepts already. But as a group, we need to look at everyone to understand it. Okay. So now the next one would be So here, if you notice, I have defined it with a root entity also. Root entity, entity specification, entity. Under that, we have entity format specification as a subclass of entity specification. So basically what I'm doing is up to this, which is already defined in the framework, I'm using it and creating a subclass. So this is the extension that I'm doing. Okay, so this part we had seen earlier in the earlier diagram. Actually speaking, this should be removed. This should not be there. Okay, because at the lowest level only we need to show the relationship. Okay, and then entity format specification position. So if you remember, there is one requirement where it says that we will have certain things positioned separately with reference to the address, right? In some countries, some let's say the suffix or a street number, a street name and some things like that will come earlier, and in some countries it will come later. And so how do we represent that is by defining the position of that. So now if I have all those as the atomic entries, when I'm combining them to create a composite or a full address, I can also decide the position of these components. Okay, and that definition is what is defined here. And so this is an entity which we had not shown earlier, but as a requirement we have this. Okay, so now if I need to do that, for this association itself I am defining a class. And that's why if you notice the name says it is association class. Okay, so this is the association class where I am defining the class for many to many kind of a relationship. Okay, by the way, are you all aware of this numbers that are shown here? What are these numbers? Either the number or star. Anybody? One too many. Okay, but what are they called? Those numbers? And what do they indicate? As part of UML, they are actually called cardinality numbers. Okay, which represents the numbers to which these two entities or the instances here, entries would be associated with. Okay, so in this case, one to many, which means one specification or one definition can have many instances here of the same definition. Okay, so that is what is one to many. Okay, you may also find one to one, zero to one, and stuff like that. Okay, here 0 and 1. So I may not have any composition defined. For the atomic entries here. Not necessary that for every atomic entries I need to define a composition. No. But if I define it, then it will have 1. Okay. So that is how we look at the cardinality or multiplicity that we discuss. Okay. Now moving forward, okay, we have discussed about format specification, both entity specification and composite atomic as part of, where is that? Let me, yeah. So we have actually now seen this and this both combined together as something like entity format definition. So both we have seen specification, entity specification, entity pattern, and composite atomic pattern. Okay, so now let us look into the next one, format definition type. How do we model that? Okay. Yeah. So if you notice, our model is growing, right? And everything is still there. Whatever that we have defined earlier, they're all still there. They are continuing. Okay. And I have not shown anything in an individual way. So this is important because we also need to know, while we are adding other things, how do we add to the existing one, right? So now if you notice, this is what has been brought in. Entity specification type or entity format specification type. See, this is again one of the, I would say, ABE, which is already there in the information framework. So what we have done is we have taken that and created a subclass of entity format specification type. So if I have created this as a separate one for address format specification, then this will become address format specification type. Okay. Or telephone format specification type. So I will, if you notice, I've just created this as one ABE and associated here. And the association name says that this entity format specification type categorizes the entity format specification. See, in the requirement, that's all has been asked. We need these things to be categorized into different types. And that is what we are showing here. So I don't need any other modeling pattern to be used here. And that is the reason why we did not choose anything here. Okay, we just define this one, and associate it with this or with this. If they are separate. Okay. So now let's look at the next part. Okay. So all other things exist now. Root entity, format specification, composite atomic, and even we have brought in the specification type, all of this. Now what we have done is, if you notice, this part is the new one. So this is where we have brought in the dependency part. Entity, format, group, dependency. Okay, so between these two, whatever a group dependency that needs to be there, okay, that can be defined here. Okay, so between the specification and the format, I will define the whatever the dependency that I have. Okay, so that is what will be shown here, and that is where I can bring in all these dependencies. Component relationship, component value name, all of these things. Okay, that's how you will see this part. Next is okay, this we have seen here. Yeah, this is what we have. We have everything defined here in this, whatever that is required. All of that have been modeled now, if you notice. So valid name is one thing which we can bring in. So that can also be addressed here if required. Or you can have another entity defined as a valid name and bring in that as an association with this. Okay. So this is how we will look at modeling the solution part. Okay. What modeling tool do you use in your organization? Visio, is it? For UML modeling? Hello? Yep. Draw by pen and paper. Okay, fine. But as an organization, you must be having some modeling tool, right? Maybe Visio, okay, Draw.io. Okay, fine. Okay. Okay, good. So now, with that, we have come to completion, or we have completed this module of what we discussed yesterday. So now we will take a look at extending the framework as a next module. Okay. So we will so in this module, we will understand how the SID or information framework can be extended and what are the guidelines. See, we have already gone through this as part of the fundamentals course. So we will quickly go through this and then try to get into an exercise of applying your knowledge for a given scenario. Okay. So, yeah. So one thing that we would like to mention here is that the framework, the information framework, has certain inherent extensibility built in. If you notice, we have the domains, and domains, they are all domain specific. right? So within a domain, anything that I would like to add, I can keep on adding as a subclassing. Okay, as a blade concept. Okay, so do you know what is a blade concept? Have you heard about blade servers? So generally in blade servers, physical servers, if you want to add a new capacity to the server, maybe CPU or memory, what we do is we bring in a new blade and insert that into the server chassis. And this you can do while the other components of the server chassis are running. Hot swappability is what we call it. But basically, if you look at the concept, um, when a blade is inserted into the server chassis, the existing components of the servers are not disturbed. Right? So that is the concept with which we look at it as a blade concept for extension part. So in this case, under resource usage, if we want IPDR resource usage as a subclass, you can create that and then continue to use that. And this can be done in any different this one. So for any different requirements. So if you notice here, for a product specification, under atomic product specification, there are multiple different types of products: network product, goods product. Okay. So whatever products that we offer to the customers, right, can all be brought under this. Sorry. All of that can be brought under this atomic product specification. If you notice, the field operation product specific is also there. Why is this? So that I'm not able to select a pen. Yeah. Although, so this is basically a field, some people related service. So that also when we define it as a product, so that can be a product shown this way. So any such product which you offer to your customers can all be defined under atomic product specification here. Now, you also have the composite product specification where you can actually define the bundles. But what we are focusing here is the blade concept here. Okay. So similarly, we have another types of blades shown as part of a party role. So if you notice, party has multiple roles. So this is a entity role pattern up to this. But that party can play multiple roles, and each of that role, like customer, organization, or a service provider, vendor, any of those things, all of that can be the subclass of this party role. Okay, so this is how we look at this blade concept. And so this is one extensibility which is already there. Okay. And this type of extension is actually called explicit modeling. Okay. So, I mean, when we use extension or when we have to add something new, this is how we add. See, everything has some pros and cons. Every type of extension. we need to understand what is required and accordingly use that. So what is the other type of addition? Other type of addition could be bringing in that characteristic specification, characteristic value pattern, right? Or a characteristics pattern basically. Okay. Okay. Now we can use any one of them. It all depends on the pros and cons, and they are mentioned here. Some of the things based on your requirement. What would be most suitable for you? You will have to use that. Explicit modeling changes the model because whenever I add a new subclass, it is something that is new which is added, and it should be shown in the model that I am using. And whatever attributes that we define there, they are all visible. And we normally use this when attributes are stable and they are all well known. And also we know the logic associated with the attribute. And for any extension, this is the best way to start. Start with explicit modeling technique. Okay. And later on, based on the requirement, if it is required to move it into characteristics modeling, we can move there. Okay. Characteristic model does not change the model here. Characteristics specification, characteristic value pattern. If we use that, it does not change the model. Retains the, let's say if I'm using information framework model, I can continue to retain it as it is. And by hiding the attributes, and also it supports the dynamic attributes. That's what we have seen earlier, right? And yeah, so this is the difference between explicit modeling and characteristics modeling. Okay, fine. So this is one way of looking at extension, and now there are a couple of guidelines, or I would say not couple, few guidelines for extension. Okay, they are, when based on the requirements, can I add a new ABE? Yes, we can. In fact, in the previous exercise, we did that, right? We added a address format specification or address format as an ABE, or address format type as another ABE. So we can add any ABEs and use modeling patterns. We saw that also in the previous exercise. We used entity specification, entity pattern, composite atomic pattern, and if required, we can use characteristic specification, characteristic value pattern, or any of the patterns basically. Okay, and you should know where to, how to place the extension, because we need to have a clarity on what is there in the base model which I'm using. Let's say if I'm using SID or information framework as my base, what is there and what is the extension that I have done. We need to have that clarity, right? Otherwise, if I want to upgrade to the next version of the SID, then we will start facing challenges. So that's why while we are extending, where do we position that is also important. But nowadays, the tools that we use for all this UML and all this part, right? They support and they take care of the placement of extensions. So do not have to worry much about it. Okay. And then can we extend the existing ABEs? Yes. And can we, when we create a new ABE, when we add a new ABE, obviously it should have an association with some of the existing ABEs. And attributes can be added and some naming guidelines. We will see this as we go forward. And I'm sure you have seen all of those things in the earlier this one. So now if you notice, uh, ABEs can be added at any level. Under product domain, as a first level ABE, product configuration ABE is added here in this case. And so product offering is a first level ABE under which these ABEs were there, level 2 ABEs. Now I can add another level 2 ABE, which is pricing logic algorithm. In fact, that has been done by the forum already. But if you want any such this one to be brought in, you can bring in at any different levels. Okay. So now what I will do is there are other things which we will look at, right? So adding the new ABs and adding attributes and then association, some of these things. How do we do it? And what are the techniques that are used is what we will be covering in the next few slides. To make things easier to understand, what I have done is I have created some sample scenario. You will not see these slides on your study material. This is what specifically I have created for understanding it better. Okay. So the scenario is something like this. Let's say there is a new telecom service provider who is setting up his business. And since he is new, he starts with one city first. Okay. And within that city, he starts providing the services. Now, since it is only one city and number of network equipment involved are less, and the people who are supporting those network equipment would also be less, and they are all within the same city. Maybe you can actually manage those things, but definitely you still need to have some kind of a fault management system, right, as part of a network operations. So that fault management system will capture the alarms. Maybe you will have something like from a network management point of view, you may have IBM Netcool, Tivoli Netcool, or maybe HP NNM, some tools, some applications like that, which will provide you alarm management functionality. So basically what it captures is that whenever there is any outage or a problem with the network element, it captures the alarm source, alarm ID, alarm severity, description and location, and many such this one. So they are all fields of this alarms table now. Right? Now can I say that this alarms is an ABE within which I have all these attributes with the fault management system in place? I have all this existing one. Okay. Now, his business grows and he starts expanding it into multiple cities and across the country. Okay. Let's say if it is a country like India or China, which is so vast. So the number of cities, number of locations, everything will be very high, and number of network elements will also be very high now, and people who are managing will also be very high. So now for the people who are, this is an application used in NOC, Network Operation Center, who are looking at this alarm console, they don't know whom to call or what is the current status of that particular problem. But if the management calls them, asking them the status, they should be able to provide the status, right? Whom is in this particular problem, who is addressing this problem, what is happening, what is the priority with which that problem is being looked into. So you need all that information. Since now this business has grown and this has become a requirement, that is when a telco will bring in, let's say, a trouble ticket application. Now, so when I bring in trouble ticket application, based on the alarms here, we create tickets here, right? And so this will also have certain attributes related to the ticket, trouble ticket status, priority, who is working on it. And in addition to that, it will also have alarm ID, which is taken from here. But if you notice here, it is a one-way unidirectional integration. So from alarm management, I am creating a ticket here. Fine. So if you notice what we have done, I have added another business entity, ABE, called trouble ticket. And I have also established association. Right? So with this, I have, so one extension, if you notice, actually what we have done is we have added one ABE, the trouble ticket, and associated with the existing ABE, which is alarms. So this is one type of extension. If you look at it from a modeling point of view. Yes. Okay. Now, with this, what happens? I'm able to create a ticket and someone is assigned to address the ticket with certain priority, and they will work on it, and I will know the status and stuff like that. But in the NOC, a person who is looking at the alarms console, for him to know that information, he will have to open the console of this trouble ticket system and take this alarm ID, feed that here into this console and search that particular alarm or ticket, then start looking at the current status or information like that. So which is not an efficient way of doing things. So what we do, can I look at this as a bidirectional integration from here to here also, and bring certain important informations like trouble ticket ID, status, priority, and whom it is assigned to. This information, can I bring it back to this? But where do I store in this alarms ABE? If I bring this information back, I need some additional fields here, right? Or additional attributes. That's what we define here when we look at it as a bidirectional integration. What is shown here is all additional fields to hold the information from the trouble ticket, maybe ticket ID, status, priority, and some things like that. Whatever is important for me, I will bring in here. So if you notice here, what I have done, I had one ABE by the name alarms. I am bringing in another ABE by the name trouble ticket, and I'm just not bringing in the trouble ticket ABE. For bringing in this and a bidirectional integration to be enabled, I'm adding certain attributes to the existing alarms ABE. Right? And so what I've also done is I've extended the same ABE, added all additional attributes to the same ABE. Okay. Fine. This is one way of looking at the implementation. But practically, if you look at it, let's say if there are 1 million alarms getting created per day, as an example. For every alarm, do I create a ticket here? Not necessary, right? So in that case, do I need to have this extension for every alarm? If there are only, let's say, some 5,000 alarms for which I'm creating a tickets out of 1 million alarms. So it is very, very small number of or set of alarms for which I'm creating a ticket. So why do I need to extend this for the entire set of alarms? I don't need, right? So what do I do in that case? Is this the efficient way of doing the extension? No. So then what we can do is I can create another subclass of these alarms, as you see here, and that will be a ticketed alarms, which is a subclass which inherits all these attributes from the alarms, and additional attributes are defined here. And now the integration happens between the trouble ticket and the ticketed alarms ABEs. And this will be the bidirectional integration. Okay. See, if you notice now, the extensions are happening in many different ways, depending on the requirement. I'm just trying to bring in some kind of a practical scenario with which you can understand the importance of this different types of extensions. Okay. So I'm doing this extension. This is fine, perfectly fine now. So if you notice, tickets are generated for small number of alarms. In that scenario, we use this. Okay. So this is the scenario with which I just wanted to explain you this extension. Now, if we look at the next set of slides, you have the various different techniques of adding attributes. So the first technique shown here is adding directly to the entity. And that's what you have certain attributes added to the entity. See, don't look at the names of these attributes. If you see our example alarms, and if it is a unidirectional integration where I just use this to create a ticket in trouble ticketing system and then bring in the information back to showcase that within the alarms table, I am extending it directly. Okay. We do this when majority of the instances of this need to be extended. That's why we are saying large number of entities to be extended. If it is small numbers, that is when we look at this alarms and ticketed alarms. So subclassing. Okay, so this is another technique, subclassing. This also we have seen in our scenario, alarms and ticketed alarms. There is one more technique wherein we look at it as a alarms extended by. Create another this one extension, and that extension is not a subclass basically, but we are adding the attributes to this only, but not directly into this. By creating another ABE or entity and adding the required attributes to this, and then extending this here. Okay. So this is the third technique, which is extension by association. Okay. So this is how we look at adding the attributes. So we have discussed three techniques for adding the attributes. There is a fourth technique which we have already discussed. What is that technique? Any idea? For adding attributes? Anyone? Is there any other technique to add the attributes? Dynamically, if I want to add attributes, what do? I use enumeration technique or name value pattern, right? Or a characteristic specification characteristic value pattern. That helps me to add the attributes dynamically, like color or that category, language, and those things which we discussed as part of the example earlier. So that is the fourth technique for adding that. Okay. And then we have adding a new entity. So if I had discussed this, right? We had alarms entity and we created a new entity called tickets by bringing in the trouble ticketing system. Right? So that is a new entity which is added and associated them. This is the integration. Right? This is one way of looking at it. Other way also we have discussed. I have subclassed this alarms into ticketed alarms when this integration happens with a smaller number of instances of this. Rather smaller number of objects within the alarms table. So I create a subclass with the smaller number as ticketed alarms, and only for those I generate the tickets. So this also we saw as example. So this is how we actually do the extension part. See, otherwise, if you just look at the diagrams, it explains the techniques. I mean, it gives the names for the techniques, but we can't visualize where do I use it, when do I use it. That's why I have brought in this alarm management and trouble ticketing as a scenario so that you can understand easily. Okay, and then there are certain naming guidelines. Are you all aware with capital case naming and camel case naming? Yes or no? Capital case naming. Yes, okay. If you are aware, then it's fine. So if you notice here, what we have is association which is being named, that is shown here, right? And that is a capital case naming. And even the business entities are also named with a capital case. If we notice the attributes here, they follow the camel case. So for attributes, and if at all you use any operations here, we do not define operations in information framework. But if it is defined, that and the attributes both will use camel case naming convention. Okay. Then we have one type of association naming, which is something like this. Business interaction involves product specification. So this, if you notice, generally we do not use this product specification. We just mention business interaction item involves as part of the association name. But if it leads to duplication, like if you see here, here also we have that. Business interaction item involves. Here also we have this. So if you have any such scenarios, we also bring in the other side of the association entity name. So if you notice product specification, which is on the other side of this association, has been used here as the naming convention. This is basically to avoid the duplication. Okay. So now naming guidelines, which is summarized here. Again, entity names are all capital case. Associations are capital case. Attributes, as you see here, and the operations or methods, if at all they will be capital case. I am sure you would have seen certain questions. How many of you have cleared the information framework fundamentals certification exam? Many of you would have cleared this exam, right? Certification exam. Yes or no? Okay. So if you have cleared, I'm sure you would have seen certain questions related to this naming guidelines. So even when you take up the information framework practitioners certification exam, there will also be certain questions related to this. Okay. Now there are other general modeling guidelines which says describe each artifact. Whatever that you define, you provide a description for that. And no multiple inheritance. What do we mean by multiple inheritance? A child class having multiple parents. Okay. So in our TM forum information framework, we do not support multiple inheritance. We say a child class can have only one parent class defined with that. Okay. But one parent can have multiple child classes. Okay. Then minimal association classes. You remember while explaining the exercise, I had shown one association class, right? For defining the association between for the composition itself, the position of the atomic component, if you remember. So that is the association class. We recommend to minimally use such things. Okay. And then only binary associations. Documentation should follow GB922 format and content. So these are what we have with reference to the modeling guidelines. Any questions on this? No questions? Then actually we have one exercise for explicit modeling here. What we will do this, we will do this extension part as exercise tomorrow. Okay. So we just have about 9 minutes. Yeah. Any questions or any other clarifications that you would like to ask? If there are no questions, then we will not get into the exercise now. Um, the next module is actually a transformation part. That also considerations, and this one we will see. Okay, what I will do is quickly I will take you through this using the framework module. Will in the remaining time we should be able to complete this, and then tomorrow we can come back and start with the either with the exercise or the other transformation techniques. This one topic. Okay, there are many different ways technology. This information framework can be used. Okay, so basically to bring in a standardization or a common terminology. Okay, so common terminology helps you to understand things internally within the organization and even with the partners. Okay, and also helps you for integrations or APIs to be developed. Okay, and there will be a lot of savings that we can have with the common terminology. So this is one of the use of the information framework. Okay, this we have seen evolution of NGOSS to ODF. I will not discuss much on this because this was the old version, and today we are at ODF. Okay, this you have gone through in the ODF course. So yeah, what we are discussing is information framework as part of the ODF, and so there are many principles of governance related to the information which is being defined. Information is a corporate asset. Information governance is a corporate responsibility, stuff like that. And all of that is defined as part of GB 998. Now, let's look at in what are the other ways I'll be able to use this information framework as part of transformation. See, in general, when we say transformation, we start with the scoping and do the business analysis. Typically, we use process framework here in this scenario. We can also use information framework for scoping. Okay, and then we do high-level solution design and low-level solution design. And here again, we'll use the information framework. Data modeling is done here. So that's shown here. Okay. And then for implementation, we use APIs and other things, and that's where we use again data model extension, which will be based on the SID, and deployment, and this is a life cycle which keeps. So this is how we will use this information framework, transformation point of view at a very high level. Okay, end to end if you look at it. And there are many other uses here. It can be used as digital to solving some of the digital ecosystem challenges. We will see that. Okay, and can be used for vendor selection and things like that. So what we will do is quickly look at this as a digital ecosystem. We will have challenges with reference to the digital transformation. what needs to be transformed with reference to process, and when I make certain changes to the process, what will be the impact on the data or information, okay, which is being managed by that process. So for that, digital transformation, yes, information framework helps. If I align with the information framework, it definitely helps. And then for the partnerships, again, this we have spoken earlier also. If I have to talk to other partners or other vendors in that scenario, and if I need to establish certain integration with the applications, right? API-based integration can be done, but definitely if I have to exchange the information, if we follow the standard way of defining the information based on SID, then it helps me to integrate with the other partners easily. Rationalization and effectiveness is something which you can look at if there is any duplication of information with multiple different applications or systems, how difficult it is to synchronize them, how do we actually bring it into a common data model or operational data store, all of that. So with reference to the framework or SID, if you analyze that, it becomes easier for us to rationalize. Okay. And agile product development is again another one where we can use this. Information framework can be used as a tool for vendor selection. What do we do is, I'll skip this and directly go to this slide. When as part of vendor selection, as part of my tender or request for proposal, RFP process, I will send out a RFP, right? The specifications, technical specifications or requirements. So now I can use information framework for defining my data requirements. These are the data requirements. I can define this as my technical requirements, and in fact I can even go to next level AVEs as my data requirements and ask the vendors to provide the conformance on this. And if vendor says yes, he is conformant with this, then now I can validate this easily. So again, this works as a tool for apple to apple comparison as a vendor selection. And this is one of the sample RFP that you can see for vendor selection. So we have based on the SID, these requirements have been mentioned here, and you can also define whether it is must or want. Any additional, see, this is again a sample. If you want, you can add any other additional columns. And in fact, you can also add, see, I said these are the information framework based requirements. So as an organization, if I feel that there are some more additional requirements, I can add them into the RFP and release that. And let the vendors provide the response with this. So then it becomes easy for me to actually evaluate the vendor and speed up the whole process of procurement. Okay. So, yeah, with that, I will stop here now. This information framework and ODA component and other things we will discuss tomorrow. Okay. So we have this part and then one exercise to complete.